Welcome back. Let's talk about the DEX and ODEX file format and also the difference between a normal Java instance and a Java instance on the Android platform, which is regarding to the ARM architecture. We do this on a very high level approach, so don't worry, we do not dive into single processor instructions, we just take this on a high level approach. Alright, on the left we have our Android applications, and those Android applications are written in Java, and this code gets loaded into the Java virtual machine. But on the Android platform it's related to the Dalvik virtual machine. And there's a difference between our normal Java and this type of Java. And this is something we want to figure out right now. So on the right we've got the source code, and if we run the source code on our laptop, for example, and compile this one, we generate a new file, which is the main.class file. And this file stores our Java source code in some kind of byte format. Now, if we would take this approach onto our Android smartphone, onto this device, for example, right here, then we would have some troubles, because this Java approach would require a lot of more resources. And if our CPU on the smartphone requires more resources, it will heat up. And heating up will also mean we use more resources on the device, and we also drain the battery dramatically. And this approach is therefore not working on battery empowered devices. We therefore have on the ARM architecture something different. And what this is it's the Dalvik executable byte format. So we take the same Java source code, but we compile it for a different architecture, the ARM architecture. And therefore we also compile it in a different byte format. In our case, this one is now called the Dalvik executable format, and we will generate those classes.dex file. I know this animation is super sick. So those classes.dex contain also the Java bytecode, but now in the Dalvik executable format. And this format is designed to work on battery empowered devices on the ARM architecture, and therefore does not drain the battery that dramatically, and also do not require a lot of more resources. And this is the reason why every smartphone device out there has an ARM CPU in there. There are of course disadvantages to this architecture, but regarding to a battery empowered device, it's absolutely brilliant to use it in this way. And this is the difference between x86 and ARM in a nutshell on a very high level approach. So what I would like to point out right here is that your PC or your laptop is running on a different architecture than your mobile device. And the reason behind this is that your smartphone needs to rely on a battery pack instead of your constant voltage or ampere out of a power supply. And therefore it has to be designed in a different architecture. And this is the reason why the Java source code has also to be designed a little bit different. Alright, now there's this ODEX file format. And what is this ODEX file format? Well, it's not that complicated, it's simply just an optimized DEX file format. And we can use a command to put this ODEX file format back to an DEX file format. And therefore this really doesn't affect us at all during our reversing process. So we just have to convert this from this ODEX, this optimized DEX file format, to a DEX file format, and then we are on our basic approach and can analyze this file. Alright, now there's also one last thing I want to point out. And this is something regarding to the classes.dex file. So your classes.dex file can only contain 65,535 methods. And if you would write more methods, then you will end up in multidexing. And you might have encountered or seen those files, because we've got a classes.dex, and in the same directory we have a classes2.dex file. And this is the reason for those split up Dalvik executable files. It's regarding to the amount of methods. And now you might think of yourself, wait, what? Whoever wrote 65,535 methods into one application? I guess this is pretty ridiculous, but it also affects, of course, libraries, frameworks, and the Android system itself. So meanwhile, by importing some libraries, you really end up easily by having multiple DEX files, because all those libraries contain a lot of methods, even if you do not use them. And the important thing right here is, if we reverse engineer and analyze those applications, we need to make sure that we analyze all classes.dex files, because we cannot tell if our necessary information are in classes.dex or in classes2.dex, or how many files we get right there. Therefore, we need to analyze all of them. And now you also know why we have multiple DEX files. So we figured out the difference between a PC or laptop which has a constant power supply, and a smartphone which needs to rely on a battery pack. And this difference also affects the operation system of this device. And we also have learned that the classes.dex is also just a Java bytecode format, but optimized for this architecture, this platform. And we also know why there can be multiple DEX files. And that's all what we need to understand for this section.